All right. Problem 9. Find all solutions. Kind of a loaded question, so as in all the infinite number of solutions. So we'll have to deal with that here. And here's our equation. First thing to notice is that we have both a tangent function and a secant function within the same equation. Anytime that happens, I know it's going to be a factoring problem. So things are already set equal to 0 for me. I'm just going to factor the tan out of this one. I'm going to rewrite tangent x times the quantity of secant x plus 2 is equal to 0. Now, if I ever want to check my factoring, I just distribute things back in. Tangent x times secant x would be tangent x secant x. Tangent x times the 2 would be a plus 2 tangent x. Okay, so since I got the same thing that I started with, I know I probably did things correctly. And the reason we factor is so we can set each factor equal to 0 and solve. Let's figure out where tangent x equals 0. Start off with that one. For 0, I'd recommend go to the graph of your tangent wave, which looks something like this. And that first wave runs between negative pi over 2 and pi over 2. So where does it equal 0? Well, the x value would just be here, would be 0 radians. All right. Now, to figure out the infinite number of solutions, I want to first find all the solutions between 0 and pi over 2. So I'm going to keep this tangent graph going here. And I have my second solution at pi. Okay, so I have solutions at 0, pi, next one would be 2 pi, then 3 pi, then 4 pi. So what I can do, the way I can express all those, is I can just say that x is equal to pi plus k pi. Okay, because each of these solutions on this graph are pi units apart. All right, let's do the other factor then. Let's solve secant x plus 2 equals 0. Okay, I'm going to subtract the 2 from both sides, so we get secant x equals negative 2. We'll think of that as negative 2 over 1 as far as our hypotenuse and adjacent side go for our secant function. Okay, we'll go to angles and standard position for that. And where are we going to have okay, the hypotenuse can't be negative, so the negative is really going to come with the adjacent side. Where we're going to have negative adjacent sides, well, that would be in the second and third quadrants. Okay, so we get a negative 1, hypotenuse 2. Okay, other side's got to be a root 3, so this is a 60-degree angle. Same thing here. We'd have our 60-degree reference angle here. And then actual x's we're looking solutions would be these angles in standard position, as in x equals 60 short of 180 would be 120 degrees, or 2 pi over 3. And then we also have 60 past 180, or x equals 240 degrees, or 4 pi over 3. Okay, so for solutions then, I'll just add these in. We'll say 2 pi over 3. And then we'll say my next solution is going to come when I make a full rotation back to the same spot. So plus 2k pi. Can't combine these, so we got to use the 2k pi's. And then all the 4 pi over 3 plus 2k pi. So I've kind of 3 sets of infinite number of solutions that I can generate.